Good afternoon, Mr. Thompson. Ladies and gentlemen, you see two names on the slide here. You see the name of Mr. Vasiliev. He's my colleague who actually prepared the slides and gave the first presentation at the previous symposium in Kyoto. I'm going to be presenting some aspects relating to monitoring, mitigating, and adapting to climate change. In this session, we are looking at how ICTs can be used to monitor climate change. Now, this is done through various means, like remote sensing, telemetry, supercomputers for climate modeling, etc. My presentation is going to look at remote sensors and how these applications can be used to monitor, predict, and detect climate change. It can be said that remote sensing applications are invaluable tools for the prediction, detection, and mitigation of natural and man-made disasters. The World Meteorological Organization has a World Weather Watch system. This consists of a global observing system which is based on the use of the radio frequency spectrum for remote sensing and dissemination of information derived by the remote sensing applications. It has a global telecommunication system consisting of both radio and telecommunication networks used for the delivery of information to the data processing centers. And it has a global data processing system mainly based on resources provided by the developed countries, but the results are made available to all countries in the world. It can be said that the World Weather Watch system relies heavily on the use of the radio frequency spectrum, which is a natural resource and needs to be monitored very carefully. The management of the radio frequency spectrum is a responsibility of the ITU's radiocommunication sector, which has to ensure the rational, equitable, efficient, and economic use of the radio frequency spectrum and the geostationary orbit, taking into account the needs of developing countries. Most people think that radio frequencies are used only for communication. However, radio emissions are also used to obtain information about the environment with which they have been in contact. This environmental information is obtained by special measuring instruments called remote sensors, which derive the environmental information by analyzing the received radio waves. So, the ITU radiocommunication sector has as its main task to ensure the rational, equitable, efficient, and economical use of the radio frequency spectrum. It also has to provide for harmonized development and efficient operation of existing and new radio communication systems, taking into account all the parties concerned. To show how important the radio frequency spectrum is in the area of remote sensing, the 15th World Meteorological Congress in 2007 passed Resolution 3, where it reaffirmed the crucial importance of the radio frequency bands for meteorological and related environmental operations and research, and for disaster risk reduction, stressing that these bands are a unique natural resource for passive sensing and that they deserve absolute protection, and they urge all their members to ensure the availability and the protection of the suitable radio frequency bands, and also appeals to the ITU and its administrations to ensure the protection of these bands and give due consideration to their requirements. The reason why there is such an emphasis is that there is a very limited choice of frequency bands that can be used for remote sensing. Take this chart, for example. Here it shows that if you want to measure the oxygen level in the atmosphere, the frequency bands between 75 and 100 gigahertz really can't be used. So there is a reason why certain specific bands need to be protected. Interference is another problem. If there's no protection given to these specific bands, which are used for the passive sensing operations, you can see the two images here. What happens when you have an interference-free image, which is on the left, and one where there is a lot of interference in those bands. The image is quite unusable. Now, the radio communication systems and applications using remote sensors are the main source of information for climate monitoring. And space-based remote sensors are the only tools that can provide environmental data on a long-term, repetitive, and global scale. In order to monitor the release of greenhouse gases into the atmosphere, for example, a satellite has been launched by the Japanese administration called GeoSat, which will be the first satellite to measure global carbon dioxide levels in the atmosphere. Here are a few more samples or examples of imagery obtained from space-based radio sensors. I think John talked a bit about it already. Stole a bit of my thunder here, but still.
I apologize.
Okay. For example, the image on top left indicates how to measure, shows a picture of the sea level measurements, and the accuracy of the measurement can go up to 2 to 3 centimeters. The image on the top right shows the global vegetation cover, which was provided by a NASA satellite. It's not a very good picture, and it shows how much vegetation is there on these parts of the Earth's surface. And the image on the bottom of the screen provides the sea surface temperature measurement in the Mediterranean area, and this has an accuracy of up to 0.2 degrees. This was obtained from the European Space Agency. In order to have precise remote sensing, it's also important to have the necessary bandwidth available for these applications. For example, to achieve a resolution of 1 meter, a specific kind of radar called the Advanced Synthetic Aperture Radar needs 300 megahertz of bandwidth. These radars provide images of the Earth through cloud covers to monitor ice, flooding, to estimate the effect of different disasters, and so on. The picture that John talked about showing the Nargis effect of the Nargis cyclone on Myanmar is an example of how we can obtain such pretty detailed images. However, radio frequency spectrum is a limited resource, and the ITU has its task fairly well cut out in trying to find a proper balance between providing enough spectrum for environmental monitoring and for other radio communication needs. These decisions relating to the allocation of the spectrum and bandwidth are taken at the World Radiocommunication Conferences, which is an international forum taking decision on spectrum use at a global level, and regional radiocommunication conferences, which take decision on spectrum use at regional levels. And they are supported by a variety of entities and organs within the ITUR sector. Having the necessary spectrum and having the necessary protection, we can carry out climate monitoring using radio-based systems, such as using satellite-based systems that collect environmental information, sea temperature, atmosphere characteristics including carbon dioxide, vegetation cover, soil moisture, ice levels, etc. We can track tornadoes, hurricanes, typhoons, thunderstorms using weather radars. We have radio-based meteorological aid systems that collect and process weather data. There are broadcasting systems and mobile systems for public warning to warn the public about dangerous weather events, or to communicate to aircraft pilots, for example, of storms and turbulence. And we have satellite systems for the dissemination of all this data that has been collected. The last World Radiocommunication Conference that was held in October of 2007 took a lot of decisions in the area of providing spectrum for climate monitoring. It extended the frequency band near 18 gigahertz by 100 megahertz spectrum allocation to provide a better precision in the meteorological satellite service. You remember I previously indicated the amount of bandwidth that was needed to carry out measurements of a specific resolution. It upgraded the status of meteorological radars to primary status. It extended the allocation of spectrum to the Earth Exploration Satellite Service in the 9 gigahertz frequency band by 200 megahertz, and adopted protection criteria for active and passive services involved in environmental monitoring of the climate. This World Radio Conference also added on the agenda of the next World Radiocommunication Conference, which will be held in 2011, a number of agenda items relating to environmental monitoring. The conference also adopted a number of resolutions in this area of climate monitoring. Resolution 612, in order to provide additional allocations to the radio location service for oceanographic radar applications. It's requesting studies to be carried out prior to the next conference. These radars can be used for tsunami detection, for example, as they can see beyond the horizon. Another resolution to carry out studies on allocation of additional 50 megahertz to high resolution sensors to allow the transmission of data. Then we have also the Radio Communication Assembly, which is the body that has the same status in the radio sector as the World Telecommunication Standardization Assembly. 2 resolutions were approved by the Assembly, which relate to disaster response and relief. The radio communication sector has an ongoing collaboration with many other organizations, and I have provided a list of them on the slide here. In conclusion, I'd like to say that radio-based technologies are an essential tool for climate monitoring and for the prediction, detection, and relief from natural and man-made disasters. It is very important that they should work in frequency bands without interference from other services, as well as have the necessary bandwidth needed to carry out measurements of the precision required. And the ITU, through its radio communication sector and the World Radiocommunication Conferences, provide the necessary radio frequency spectrum and orbit resources for satellite systems and other radio communication systems which are used for climate monitoring. That brings me to the end of the presentation. Thank you very much.